What we're going to go through is the architecture patterns of how to integrate Power BI and Databricks together for streaming use cases, for batch use cases. We'll go through the performance tuning tips for Power BI, Delta Lake, as well as Databricks SQL. And for security elements, we'll go through access control and networking, and then we'll leave some time in the end for Q&A. Again, ask your questions in the chat. Some of my coworkers are also in the call, so they can potentially help you while we're going through the content. Right, so the first bit of architecture. So in general, you can do batch and streaming, both with Databricks, and the general kind of architecture is you go through the medallion architecture and your data gets stored in the gold table. You can then use Databricks SQL or Databricks SQL Warehouse to connect to the gold table to serve Power BI. This is a general pattern. What it really means is below scenarios. So first, for batch scenario, what you can do is you can either use Delta Live Table or normal notebooks orchestrated by workflows to do the data engineering. Your data will flow through the medallion architecture and then get stored in gold tables. What then happens is you use Databricks SQL to connect to gold tables with Power BI. In this particular scenario, Power BI will import the data from gold tables and cache it in Power BI memory. So it's really fast for Power BI to react to any kind of report or visualization interactions. And also there are some manipulations that you do in Power Queries that's not allowed for direct query. So you actually have to import the data. And this is a very common pattern that we see with customers. Second scenario is you again do the same things in Delta Live tables or notebooks and Databricks SQL, but the Power BI and you will use something called direct query. This means the interactions that your users will do in the reports and the visualizations will generate a SQL query down to Databricks SQL Warehouse, and that SQL query gets executed in Databricks, and the result comes back to Power BI. And the difference is typically people will use direct query on one of the three kind of scenarios. One is if your data set is too big for Power BI to cache everything into memory. So this will depend on whether you have a Pro license or a Premium license. So if you're on Pro, then your data set limit is 1 gigabyte. And if you're on Premium, depends on what tier of Premium you have. The P1 Premium starts at 25 gigabytes of data sets. If your Power BI data set is beyond that limit, you actually can't do pure imports. You have to resort to some sort of direct query that sends down to the data source. And that's one of the reasons commonly people will use direct query. Second scenario where people will use direct query is when your data is refreshing quite frequently in the data source. Now, in the batch scenario, this typically doesn't happen. So you would then potentially want to use direct query for the same, for the third scenario, which is you have your Unity Catalog set up and you don't want to duplicate a security model in Power BI, and you want to utilize Unity Catalog to govern all of the Power BI users' access as well, then you will use direct query. So in a batch scenario, if your data set is bigger than what your capacity allows, and if you want to unify your governance model with Unity Catalog, then you would want to potentially look at direct query. And the third scenario is where we see where 90% of the customers will sit, is a combination of these, right? So composite model says for a very, very large direct, like fact table, I would like to do direct query. But for smaller tables, smaller queries, I potentially can have things like aggregations set up in Power BI so that that aggregation is cached in Power BI memory. And if my user is doing an interaction that can actually hit that cached aggregation table rather than my like fact table in the data source, I will hit that aggregation table instead. So the way it's set up in the Power BI modeling world is your fact table is set in direct query mode. Your dimension table is set in something called dual mode. This means Power BI is quite intelligent. And when it makes sense to send the query down to Databricks, it will send the query down to Databricks. When it makes sense to hit the aggregations in the cached result in Power BI memory, it will hit the Power BI cache instead. And then there's aggregation tables that has relationships with the DIM tables, and the aggregation tables are typically cached in Power BI. And this works really well because then you are taking advantage of the performance of import model as well as the kind of data size limits of, or the lack of data size limits in direct query mode. For streaming is slightly different. So for streaming, you can use Delta Live tables if you want to simplify your streaming logic without having to manage your infrastructure or checkpoints. And your Delta Live tables will write into a Gold tables, Databricks SQL Warehouse will pick it up and serve it to Power BI. Power BI has this really cool feature within desktop that you can toggle on. It's called auto page refresh. So it only works with direct query. And the only sensible use of this is if you have premium capacity, because if you have premium capacity, the auto page refresh will go down to once every second if you want that fast of a refresh. Basically, what it means is on a normal direct query, if your user is interacting with Power BI visualizations, then the Power BI will send down a SQL query down to the Databricks SQL warehouse. But if you're streaming, you don't want to wait for users to interact with your reports. And you want the streaming data to be kind of changing and visualizing in Power BI all the time. So you will set the page auto page refresh to the latency that you're generating the data or the processing the data. Let's say you're streaming data into Delta Live table every 5 seconds, processing it every 5 seconds. You could set up auto page refresh in Power BI to match that and get the visualization to refresh every 5 seconds rather than kind of wait for user to interact with the reports. The second scenario is similar to the first one, just on top of the first one, it will incorporate the composite model kind of logic. So you will have your fact table on direct query and auto page refresh, and your DIM table in dual mode. And so it's easier for Power BI to figure out, if I have a query that's just hitting the DIM tables, I don't have to go down to the data source and query the fact tables. The third scenario, you will use something called structure streaming. This is native Spark instead of Delta Live tables. And structure streaming has been there forever. And you're streaming data directly into Databricks, and you have a choice whether to persist the data in Delta or not. And then at the end of the structure streaming pipeline, you'll call the Power BI API and push the data as a micro batch to streaming dataset API in Power BI. So this is a Power BI service only feature. And this only works on a single table. So it doesn't have a fact table or DIM table, doesn't work on a whole model. But if you have, let's say, IoT data that you are visualizing, and it's just a single table, and it's kind of, you don't care about whether the data gets persisted or not, and the latency is more important. You could do structured streaming, like not persist data in Delta and streaming it into streaming data sets in Power BI. The downside of the streaming data set feature in Power BI is that the data doesn't get persisted in Power BI at all. It gets visualized and thrown away depending on the historical window that you define, and you can't define a very big window. This will basically throttle Power BI and tell you that it's too much for me to handle. I can only do like 1 minute or 5 minutes, a very short window, but it's very good for low latency type of requirements, if that's something that you're considering doing. An alternative for this is you still do structured streaming, but at the end of the structured streaming pipeline, you'll persist it in a gold table and then visualize it through Power BI via SQL Warehouse. Again, you can choose either direct query with auto page refresh or the composites model. The idea of this is you introduce a little bit of a latency by writing to the Delta table in the at the end of the pipeline, but then you have your streaming data persisted in the lake, and you can do later future analysis with that Delta table, if that's something that you have a need for. So performance. We'll go through 3 elements of performance. First is Power BI. There's quite a lot of knobs to turn in Power BI in terms of performance tuning. The first thing you always want to think about is am I using import or am I using direct query? Depending on your security model, depending on the data set size, you want to decide. And also latency requirement as well. Typically, everything cached in Power BI is a lot faster if Power BI has to go to any kind of data source and fetch the results. Please use star schema with Power BI, because Power BI really likes filters and aggregations. If you think about how star schema is built, the dimension table will allow Power BI to do filters, and the fact table will allow Power BI to do aggregations. And this is where star schema will really excel in the world of Power BI. And then again, consider doing things like composite model aggregations that will help you take advantage of both import and direct query mode. Power BI did come out with something called hybrid table last year, which is quite cool, because in the same table you can have some of the tables that some of the rows of the table that is cached, and some of the tables are direct query. So let's say if you have a fact table that has 5 years of history, and a new data is streaming in all the time for that history, and you want the latest data, but it's too big of a table for a Power BI to kind of cache it. What you can potentially do is to utilize hybrid tables to kind of divide up the tables so that some of that history is cached, but then it also hits direct query for like the latest data. So you can set it up as part of the incremental refresh setup for Power BI using hybrid tables. If people are not familiar, there is a toggle within the relationships of a model view in Power BI called referential integrity. So when you're building relationships in a model view in Power BI, toggle on that referential integrity if you're doing an inner join. This is because inner join execute a lot faster than outer joins. So if you toggle it on, Power BI knows it's an inner join, it will generate an inner join SQL query done. query folding and push down transformation logic. I've seen this a lot. People like to cache everything in Power BI, do a select star from a table in the M query, and then bring the whole table into Power BI, and then do all the transformation in either Power Query or DAX. It's not impossible to do that, but Power BI is not built for a large-scale data processing. It is a visualization tool. So what you want to do is to utilize query folding, is to kind of transfer all of the transformation logic, or majority of the transformation logic, especially very complex ones, into Databricks, either build those logic into Gold tables or build views on top, so that Databricks can leverage large scale kind of Databricks SQL compute to actually do those transformation logic, and leave Power BI to do the lightweight of visualization and kind of formula engine type of work. Use efficient DAX calculations. I don't think my former customer from from Microsoft is on the call. They were using a lot of RankX in their logic on a 40 million row table, and they were wondering why is that slow, right? So rank is always better than RankX in terms of performance, and there's a lot of Power BI documentations on, these are the DAX calculations to avoid if you don't have to use them. There's a lot of DAX calculations that are built for a specific purpose, and a lot of people use them as a general purpose DAX calculations, and that will result in a lot of inefficient kind of execution of Power BI pushing down SQL queries. So try to use efficient DAX calculations if you can. This is a relatively new feature. It came out earlier this year from Power BI. Basically, it had a lot of parallelism settings you can do with TMSL, or the settings within Power BI desktop. These collectively will determine the query parallelism from Power BI to the data source, including Databricks. So if you're in a world where you're using classic and pro SKU of Databricks SQL, you know exactly how many parallelism your SQL warehouse can handle, depending on how many clusters you have in that SQL warehouse. Time that back 10 is the number of parallelism that your Databricks SQL warehouse can handle. So you want to tune your Power BI parallelism to the level that Databricks can handle. That will give you the best performance possible. Just bear in mind the default setting in Power BI on these are really, really low, and also slightly depends on the premium capacity you have. At different capacities will have slightly different default settings. But the idea is you can go in and change these settings in Power BI so you can increase the parallelism. In Databricks SQL serverless world, because we have intelligent workload management where you have a fast lane and a slow lane, and a lot of the fast queries will bypass the queued up slow lanes. You don't have a very kind of clear note on what is the parallelism. So the best thing to do there is to test it out a bit, increase the parallelism setting in Power BI, and see depend on the t-shirt sizing of your SQL warehouse, what setting in Power BI will result in the best possible kind of performance for you. And then just a couple of good practice things is reduce the amount of visuals you have in a page. One, it's not very pleasant if you have 15 visuals in a page, your users don't know where to look. Two is every visual will generate at least one query down to the data source. So if you have 15 visuals, it will generate at least 15 queries down to the data source. And if you have a lot of parallel kind of users, and this is direct query, by the way, for generating queries down to data source. If you have a lot of concurrent users, that could generate a lot of queries down to the data source. So try to limit an amount of visuals. So the best practice is maximum amount of visuals you want to have on a page is 7. And you can do less than that if you want, but don't do double amount of that. That will make your visual really slow and really unpleasant to look at. So the default behavior in Power BI is every time you interact with a slicer, every time you interact with a filter, every time you interact with a visual, it will like compute and generate queries down to the source. If you're on direct query mode, what you want to do is to do the apply all or clear all slicer button. So you can choose all of the settings you want within the slicers and then click the apply all button. And then Power BI will only generate one set of queries instead of every slicer you touch. The Power BI will send down the queries to the source, because these intermediate steps, when you're, say you have 5 slicers and you have filtered on 2 and you want to filter on 3 more, Power BI is already on the way of generating those like intermediate steps for you, and those results are not useful for you. You want to do all of the slicers before you do the apply all button, so you see the end result that you're looking for. The last bit is similar to the above points. Power BI desktop has this setting called query reduction. You want to potentially toggle that on because again, it's for filters and for cross highlighting. You can turn off like cross filtering, cross highlighting between the visuals using query reduction. And you can do the same apply all button for filters if you're toggle on query reduction in desktop. In terms of performance of Delta tables, so this will depend on whether you're actually persisting to Delta tables and whether you're using Delta Live tables or not. But in general, we see people sometimes tell us that they're using Parquet in Databricks and they're communicating to Power BI. And as soon as they switch to Delta, the performance is much faster. And please use Delta, because Delta gives you a lot of performance benefits if you are on Databricks. So do not use like CSV or Parquet files. You can, but they won't give you the best performance. In the table definition, set not null where possible. This is because Power BI tend to generate more efficient SQL queries if it knows certain columns are not null. And use predictive optimization. This is a relatively new feature, came out last week, is currently in public preview. Basically, it uses machine learning to determine for your Unity Catalog managed Delta tables. It will determine when to run optimize and when to run vacuum, and basically auto compact your smaller files into bigger ones, and it's faster for Spark to read. And if you are not in the Unity Catalog managed table world, you want to still use something like Auto Optimize. Basically, you can run that, and Databricks will do the auto compaction for you. And Auto Optimize is automatically run on the Delta Live tables. So if your table is written by Delta Live Tables, the optimization is taken care of for you, so you don't have to worry about those. Run analyze tables regularly. This is because if the statistics is updated regularly, then it's better for data skipping. When Power BI sends down a SQL query and the SQL warehouse is reading your Delta tables, if the statistics is updated, it will be better at skipping certain files, not to open it and then read it and close it. So it will be faster. Use Z order. This is a kind of a feature that's been there for a while. Essentially, if you're doing join keys or and like a frequent selection kind of query predicates, you want to Z order by that column. And in the world of old kind of rigid partitioning, it's better to Z order than to partition on a table if your table is like smaller than 1 terabyte. But we did announce liquid clustering in, I think, June this year in Data and AI Summit. It's currently in public preview. The idea is liquid clustering will replace Z order and the rigid kind of partitioning in the end. Again, you might be in an organization that public preview feature is not available to use. You have to use a GA feature, so just wait for a little bit until liquid clustering kind of becomes GA. The idea is with the white space filling that liquid clustering is doing, you will see better performance than both the Z-ordered Delta tables as well as the kind of traditional partitioning tables, especially if your partition is like super skewed, things like that. Avoid using wide data types to reduce the model size of Power BI data sets. And this is particularly true for like import mode, because you know, sometimes if you're not careful and you have a lot of wide data types, your data model can exceed your 1 gigabyte of model size in Power BI. So you want to potentially kind of, you know, take a look at your data types of columns and make sure you're using the right types to reduce the model size. In terms of Databricks SQL, first of all, a lot of people come to us and say our Power BI is not performing well on Databricks. And the first thing you look at is they're using an all-purpose compute. Please don't do that. Please use Databricks SQL Warehouse. One, it's cheaper. Two, it's optimized for BI workloads. So you will see a performance improvement if you use SQL Warehouse instead of all-purpose compute. Second of all, think about the different degree of separation when it comes to SQL warehouses. So now we come out with system tables. You can actually kind of divide up the cost of your SQL warehouse by the cluster and potentially cross-charge for your different business departments. So what you want to do is potentially use a different SQL warehouse for different business units if you want. Or typically we see people use or you can use the same one, but a lot of times people use a different SQL warehouse for the do a query Power BI report versus the import, because the size is different, the concurrency is different, so they had different settings on the Databricks SQL warehouse to cater for different purposes as well. And you want to size your SQL warehouse right. So you want to scale up if your data size is bigger and your calculation is more complex. You want to scale out if your like you have more concurrent users and concurrent queries coming in. And you want to kind of choose the right type for data warehouse. I know I think majority of the people on the call is actually from highly regulated industry, so it depends on whether your company would allow serverless or not. But think about these features. So first of all is predictive I/O, which is a feature that's available in Pro SKU as well as serverless. And predictive I/O is really helping you to run those like needle in a haystack query really fast. So if you have a query where you're finding a single row in a billion row kind of fact table, predictive query really excel on that front. So if you can't use serverless, then use Pro for that. Intelligent workload management is only available in serverless today. And this is basically every cluster's got two lanes. One is the normal lane, one is the fast lane. And what happens is if you have a query that's stuck in the more normal lane, the fast lane will let all the short running queries through, bypass that query that's stuck, that's running for a long time. So you're not queued up because of that single query and that serverless feature that's available. And also serverless comes with result set caching. So if you have, the same queries that's running over and again, the result is cached and the serving will be really fast. The last bit is to potentially look at the query history in your SQL warehouse. This is because you can identify the frequent running queries coming from Power BI and determine your like frequent join keys that you can see order by, and you can do the delta optimizations on top. One thing I'm going to add on the SQL warehouse type is if you're running streaming, just use a classic or Pro cluster because it's going to run 24/7. You don't get the advantage of, shutting off the cluster when it's not used. And if your load is relatively stable and you are more cost conscious, use a classic cluster in SQL Warehouse to have it running 24/7. If you're streaming and you're more performance kind of conscious and you want to use things like predictive I/O, latency is more important, then potentially consider Pro SKU for streaming as well. In terms of security, we're going to go into access control first. So typically you are looking at access control from Power BI to Databricks in this scenario. The first scenario is you have import mode, composites models, aggregations, and hybrid tables. And these are communicating through SQL Warehouse use a service account. So how it's set up is you publish a Power BI data set to Power BI service, and you have to set up a credential for that. And what you want to do potentially is to use a service account. So it's the same service account that's not attached to a single user within your organization. So if someone leaves, your data set doesn't just not refresh from that point onwards. And you will basically use that service account as the identity that's talking to SQL Warehouse. And typically in an import or composite model world, the ACOs or access control is set up in the Power BI security model. So in Power BI, you can do row level security set up so that you can assign a security group in AAD or Entra these days, or a single user to a particular role that you want them to see, or particular subset of data you want them to see. The same logic applied to the second scenario, which is you're using direct query. So like every visualization interaction that your user does, Power BI will send a SQL query down to Databricks SQL. but you're still setting up a service account. It's still a account that doesn't belong to any single person within your organization. As far as Databricks is concerned, it's just this fake service account that's talking to Databricks SQL, and you have your table echo set up in Power BI. The difference between the first and the second is, again, the scenarios you potentially want to use direct query for because your data set is too big and so on and so forth. The third scenario is interesting. It's the case where you actually don't have to set up a security model in Power BI. You can do a direct query data set in Power BI, use the AAD pass-through in Power BI, or it's called Entra these days. The idea is when you set up the credentials in Power BI data set, there's a toggle that says allow users to pass down their identity to the data source, and you want to toggle that on. What happens is every time Power BI generates a query because a user interacts with a report, it will send down the identity of that user from Power BI to the SQL warehouse. The SQL warehouse, if you have Unity Catalog set up, will check the Unity Catalog whether that user have access to that table or that row or not, and then send back the results. And that way you don't have two separate security models, but then again, you might not want everything on direct query. So what we see people do is typically a combination of all of these scenarios for different use cases and for different BUs. The last kind of scenario is basically for report authors or data sets authors where they are using Power BI desktop. They typically use their like PAT or AAD OAuth to talk to the SQL warehouse, and at that point SQL warehouse will check with Unity Catalog if that user have access to that table or that column or that row or not. So it's just depending on the user identity of the report author. Right, networking security. So networking security is important for highly regulated industries. And we have two features would allow the high reg customers to say the people who are hitting or opening my Power BI workspace can only not Power BI workspace, Databricks workspace can only open my Databricks workspace if they are on my company VPN. Right, so if they are on my VPN, if they're within my network, they can hit the workspace. And this affects Power BI because the workspace is in control plane, and so is how Power BI is communicating to Databricks is hitting control plane. So if you say, I want my end users to be on VPN when they use my workspace, and you will toggle on things like front-end private link or IP access list that says, okay, your user has to be on private link or your user has to be on this range of IP to hit the workspace. Power BI needs that as well. If you toggle these on and you don't do anything, Power BI cannot talk to your Databricks workspace. So what you need to do is to either set up a Power BI virtual network data gateway or set up an on-prem gateway. It's called on-prem gateway, but it's actually a gateway hosted in a VM in the cloud. Right now, I would recommend you to go with the second option of on-prem gateway. This is because even though it involves a bit of a setup and requires like a VM, it actually can be scaled, and there's a lot of documentation around how to manage a data gateway for Power BI, how do you do scaling and so on and so forth. The reason I'm not recommending the VNet gateway is because one, it's still in preview. Two, you can't actually scale it. Right now, it's like very limited hardware that is actually powering the VNet gateway, and that is very likely going to become a bottleneck for you if you are using the VNet gateway. They're not GAing it this year, but maybe if they do GA it next year and they fix the hardware issues or the auto scaling issues in VNet gateway, then that will become a viable option for you. Again, not everybody has front-end private link or IP access list. If you don't have these features, you don't need a gateway for Power BI to talk to Databricks. One thing is, sometimes people say, oh, I toggled on security cluster connectivity and all of a sudden my Power BI doesn't work. Secure cluster connectivity has nothing to do with Power BI. SCC is actually securing the communication between your data plane and your control plane. But Power BI only talks to the control plane. It doesn't go through that route that SCC go through. So if you have toggled on SCC and you realize Power BI stopped working, this is likely that you're either toggled on you're probably toggled on front-end private link in the process of upgrading to SCC, because they're the same upgrade path, like the front-end private link and SCC. So just be careful if you're just doing SCC. Do not enable front-end private link if that's not what you wanted to do. A bit of a bonus thing. So a lot of organizations use Excel. All roads lead to Excel. So today, if you Google how Excel connects to Databricks, it will give you a documentation of how your users should connect to Databricks using an ODBC driver and how to install a ODBC driver for your end users. Majority of the Excel users won't be messing with an ODBC driver on their laptop. So, and then there's another option of DeltaShare. You can use DeltaShare. It's a variable, like a variable option. But this is also an alternative to DeltaShare. This is publish your data set to Power BI and use Power BI as a source for Excel. So like your data set is already very clean, typically when it's published to Power BI, and then you can use Excel to connect to it, give your end user access to the data that you have in your gold tables or silver tables through Power BI in Excel. That's also a variable kind of option if that's something you're looking at. It'd be easier to set up than DeltaShare. It certainly will be a lot easier than ODBC driver from your end user perspective. I think that's everything I have. I can share the deck. There's a lot of resources that you can read up on in terms of different features and best practices and so on and so forth. I will send this deck out as the follow-up for this session, and I think we can look at the Q&A.